Hello, welcome to a new chapter that doesn't have trig. I know you're probably screaming with sadness because you loved the last two chapter units full of trig, and now we have none. But that's okay. We're going to do conics. I love conics. Conics are fun. We are going to talk about conic sections. There are 4 of them. If you want to stop and pause this video anytime to draw or take a definition or graph, please do so. 4 types of conics are circles, ellipses, parabola, and hyperbola. Now, what is a conic? So a conic is a right double cone. This is a cone, and you put it on top of another one right at that point. And you slice through the conic with a plane. If you slice it straight across, think of an ice cream cone, just chop off the one end, you would have a circle. If you go out a side, you would have an ellipse. If you cut just the end part off, you have this parabola. And if you cut from top to bottom, you have 2 of those looks like parabolas, which we call a hyperbola. Today, we're going to talk about the first type of conic, which is good old parabolas. Okay. The definition for parabola, again, you can pause this if you want to, is this set of all points in a plane that are equidistant from a fixed point called a focus and a specific line called a directrix. Okay. So I just want you to notice what I've drawn here. Your parabola, you're used to seeing your parabola up and down, but we can now have right and left parabolas. What you're going to have to find on a parabola is this vertex right here. And then from the vertex to a fixed point here and here. That point is very particular. We're going to find that in a minute. This point right here is going to be called your focus. This point here is actually a point on an imaginary line called a directrix. These 2 points are on what we call the axis of symmetry. We should know that. That's where it folds the parabola in half, okay? One thing I want you to think of a parabola, the focus always needs to be caught. Always needs to be caught. If it's up and down, it's going to be caught up here. Down, you're going to catch it down here, okay? It's always within the catching point. All right, so let's do a few examples. Very easy today. Now, I am going to give you, I hate doing this every year, but I know it's helpful for some people. I'm going to give you the formulas. These are the 5 things that you're going to find on every single one of tonight's homework problems. I want to see these 5 things. I want to know, is it an up-down or is it a right-left parabola? Where's the vertex? What's the focus? Where's the axis of symmetry? What's the directrix? I need these 5 things. Well, depending on if we have an up-down or a left-right, these could change. I'm going to give you the formulas. I don't memorize these formulas. Honestly, don't even like them. But I'm going to give them to you because I know for some they help. If you are an up-down parabola, I want you to notice that your x is being squared. And that should make sense because if you were to draw x squared right now, wouldn't it look like it's up-down? Okay, so that's the first thing you're going to look for, that the x term is squared. So we know it's up or down. Now, how do we know if it's up or if it's down? Well, you're like, well, it's probably deals with negatives. Well, what up here is negative? Well, it's this p right there. If the p is positive, it goes up. If the p is negative, it goes down. So that p is important to us. The vertex of your parabola, HK, always in alphabetical order, HK. The focus of your parabola, well, it would be your H, and you would take your P, and since you're an up-down, you would add P to the K. The axis of symmetry, your axis of symmetry is always written as a line. It's either x equals or y equals. Since this is an up-down, this axis of symmetry right here, this obviously would be x equals what? H, 0. The directrix, again, is also a line. These two are perpendicular to each other. So you would have y equals, and it is p the other direction. So it'd be k minus p. Now again, I have a hard time memorizing these. I'm not going to expect you to. If you listen to how I do the next few examples, you won't need to. But for those of you who like this, I'm writing it down for you. All right, so really the most important part, if it's up or down, your x is squared. What if it's left or right? Well, if it's a left or right, then your y is squared. Your y is squared, okay? So the p still tells us a certain direction. If the p is negative, where do you think it's going to go? To the left or to the right? Yeah, it's going to go left if it's negative. If p is positive, then obviously it goes right. Vertex, be careful here. It's not at KH. It's always at HK, okay? Always, always, always at HK because we have to go x-axis, y-axis, HK, HK. Focus, different now. You're going to add P to the H. Axis of symmetry, it's not going to be an x equals anymore. It's going to be a y equals. Y equals K. Your directrix, x equals, because again, they're perpendicular, H minus the P. Okay? All right, so pause it if you didn't get a chance to write this all down. And then let's move on to what do these actually look like. Let's graph and do an example, okay? So here we go. Graph y plus 5 squared equals negative 12 x minus 2, okay? So the first thing you need to do is tell me, is it up, down, right, or left? Well, if the y is being squared, then it is left or right. If the y is squared, it's going to open left and open right. Well, how do I know which way it goes? Does it go left or does it go right? Which one do you think? If that's negative, it goes left. Okay, so I already know it's going to open up to the left. Next thing I want you to do is look at this number right here in front. That is equivalent, according to your equation up here, to 4p. To 4p. So if 4p equals negative 12, what would p be then? What would p be? P would be negative 3. That's very important. Just keep that on the side for right now. All right. So number one, up, down, left, or right. We know it's left because it's negative. We know it's left and right because it's y squared. Number two, I want you to tell me where the vertex is. The vertex is always HK. Your H is always with the X. The K is always with the Y. And you change the signs. So if it's minus 2 right here, you're going to call it 2. If this is positive 5, it's going to be negative 5. H, K. Now, at this point, I actually start to graph. Okay, so I am going to go to my graph right here, 2, negative 5. So 2, negative 5 would be right there. I'm going to open it up to the left. So I'm just gonna, and I don't need you to be too crazy here. Just open it up to the left. That's where it's opening. This P is your magical number. That P, you are going to move, if this is your focus, 3 units this way and that way, to the right and to the left, because that's how we're opening. So 3 units to the right, 1, 2, 3. 1, 2, 3. Which one of those 2 dots that I just drew is your focus? The one that's being caught. Number 3, your focus is located at negative 1, negative 5. See, I didn't use the formulas. You can if you want to. I don't. This other point is not a point. It's actually a point on a line that the parabola imaginarily sits. Think about it like that. So draw this dash right here. This is called your directrix. And you write the directrix, which is a line. Lines are always written as x equals or y equals. Is this an x equals or a y equals? Hoi vernox. Hoi vernox. This is vertical, vernox, x. X equals what? Where did I land? X equals 5. 1, 2, 3, 4, 5. And then the last thing you just need to find for me is the axis of symmetry, which you should remember. Axis of symmetry contains the focus, the vertex, and the directrix. And again, it is an imaginary line. So if this is x, this has to be y. And that makes sense. Hoi, horizontal, y. Y equals what? Where did I just cross through the y-axis? I just crossed through -5. Okay? Now, I just did that very slow, but you'll get, I promise you, you'll get much faster at these. Okay, let's do another example. 8 times y plus 3 equals x minus 4 squared. If you want to pause the video, you can and do it yourself, or you can watch me. First of all, I don't like the way this is written. I like my squared to be on the left side. That's just me. Okay, so x is being squared. X squared, you should always think of x squared like that. So it's an up-down. Is it up or is it down? That number is positive, it's up. Okay, while we're here with this number, set that number equal to 4p. So divide by 4p would be 2. Now find your vertex. Change the sign h, change the sign k. 4, -3. Right here, I graph. Right here. So go to 4, and then go down to -3. That is your vertex. You're going to draw this up. Don't draw it too tight. Just like that. You're going to take your magical number 2, and from the vertex, you're not going to go right and left. No, you're going to go up and down because it's an up-down graph. So you're going to go up 2, 1, 2. You're going to go down 2, 1, 2. Which one of those dots is your focus? Yeah, the one that's catching it. This dot is an imaginary directrix that the parabola is sitting on. So let's just take an opportunity to write this down. Your focus is located at 4, -1. Your directrix, which it's sitting on, is now a horizontal line, which means it's y equals what? 2, 4, -5. That means your axis of symmetry has to be the perpendicular to that, which is x equals, and your axis of symmetry has all these 3 points on top of it. X equals 4. See? That was much faster. Much faster. All right, they're going to throw this at you tonight. Y squared equals 8x plus 48, and you're like, I don't know how to draw it. Well, you kind of do. Y squared, there's no other y. You can rewrite this as y minus 0 squared. This side, what could you factor out? An 8. X plus 6. Oh, now you can graph this. You can go through the whole thing. Is this up, down, left, or right? Y squared. Well, it's a right or left. Is it right or is it left? If that's positive, it's right. Vertex, where's your vertex? HK, 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 -6, 0. What's your P? Divide that by 4, 2, and et cetera, okay? I'm not going to graph this one because I think if you understood the last two, you'll be good. Because I want to get to this. This is our last important thing, okay? My students are so good at completing square because of this chapter. This is the whole point of me doing conic section, because you are going to learn to complete the square. We are going to write a parabola in standard form, which is the form we just been working in. If they give this to you, you need to learn how to write it in standard form. So pay attention. You are going to keep your squared term on one side, and anything that's not squared moves over. So all the squared terms are going to stay on that side. So 2x squared minus 8x, you're going to put plus blank. These two things that are not squared, you're going to move over. And change their signs, obviously, when they move over. And then put plus blank. If there's a number in front, like there is right here, you're going to have to factor that out. This you can just leave. Now, how do you complete the square? You take half of the middle and you square it, and you put that number here. What is half of -4? It's -2. What's -2 squared? It's 4. So this, whatever you took half of, by the way, that's what this side factors into. This factors into x minus 2 squared. And then that 2 just comes out. Where did I get that number? It's half of -4. These two need to be half of each other. Now, normally you'd just be like, oh, do I plus 4 here? No. No, 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 no. Why? You had factored out a 2. If you factor out a 2, then you should have put what here? 8. Where am I getting that from? 2 times 4 would be 8. I must have factored out a 2 from an 8. So that's what needs to go here. So we've cleaned up this side. Let's clean up this side. This would be -y plus 2. And then last and final thing, I just want to, again, I'm trying to make this in standard form, which means the squared side has to be by itself. So I'm going to write this as 2 times x minus 2 squared. I'm going to factor out a -1 from here. And then all you have to do is divide by 2. So in standard form, it's x minus 2 squared, the squared term by itself. -1/2, that's going to be your p. And then y minus 2. Now, I would never let you graph this. This is pretty terrible to graph. Think about that. You would have to divide that by 4, which is -1/8. Ugh, can you imagine going 1/8 up and down? Oh, that would be terrible. All right, I'm going to do it one more time. I know this video is getting long. I'm sorry. We're just got one more example to do. Y squared, y, 15, 12x. You're going to keep all your squareds on one side. 3y squared plus 6y plus blank equals, move everything else over. So 12x stays positive, but 15 becomes minus 15 plus blank. Factor out a 3. Now complete your square. Take half of the middle, square it. Half of 2 is 1. 1 squared is 1. Do I put 1 here? No. I put 3. Please, that is the problem I get every year in this chapter. We're going to rewrite this as what squared? Well, y plus 1 squared makes this trinomial. Put your 3 out in front. Simplify this side. This would be 12x minus 12. Oh, what could you factor out there? Factor out a 12. And then what do you do last? You want your squared term by itself. Yep, divide by 3. So this is a, this is a left and right parabola. This one is much more graphable. All right, so you are going to do page 428. You are going to graph numbers 1 through 4, 15 through 18. I want to see all those 5 points. And then do 100 to 103, just some good reminders. Thank you. Bye-bye.